Okay, so um, does the piston move up or down? That just has to do, so you can figure that out as soon as you can figure out the sign of W. Yeah, so work is done on the gas. That's sort of a sneaky way of saying that negative work is done on the surroundings. And so W is negative 300. So the piston moves down. Now that we know that W is negative 300, to calculate the change in internal energy, the first law of thermodynamics says the change in U is equal to Q. That's the heat added to the gas, so 200, minus this negative 300. And so you get a change in internal energy of positive 500 joules. So 500 joules is added to the gas. Any questions about any of those so far? And then the last one, a monatomic gas. The only reason that that's ever given is so that you know that this is true. And so 500 is equal to 3 halves times 3 times 8.314 times delta T. So what do you get for delta T? So 13.37 degrees Celsius or Kelvin. We're talking about a change in temperature, so Kelvin and Celsius are the same. Any questions about that? Okay, so now you can look at the practice problems and you should be able to do any of the practice problems that deal with processes. Any of those 4 process types, you should be able to work on those. The next thing we're going to talk about is heat engines. And I'll just give like an introduction to this and then we'll get into it next time. Yeah, next time. So here's how a heat engine works. It's basically just taking advantage of this same relationship between heat added to a gas and work done by a gas that we've been talking about. You can think of setting up a cycle like this. With a cylinder and piston in the middle. And the piston's connected to the walrus. The walrus is getting fatter. And then on the other side, there's another section there, and then this goes around. Okay, so the chosen material is a gas that's flowing through this cycle. There is a valve here, I'll call this A, and a valve here at B. And those open and close at specific times. This is called the boiler. And the gas in this part is energies added through heat. That can be done by a coal fire, or in modern heat engines, that's done through nuclear fission, but it's still the same idea. You know, with nuclear reactions, you can get this a lot hotter than you can with fire. Then over here, this is called the condenser. Gas moves through the cycle this way. And let's just think sort of step by step what has to happen. And I'll call this C. Okay, so there's gas in here being heated up. Okay, it's trying to expand, but it's not allowed to if this valve is closed, right? So let's start by saying the valve at A opens with the piston in the down position. And because that high temperature gas wants to expand, that pushes the piston up. Okay. And then valve A closes when the piston gets to that highest position. Now go to the valve at B. That opens with the piston in its highest position. It allows that high temperature gas to flow into the condenser. And then valve B closes with the piston at the bottom. This condenser cools down the gas, so you have the high temperature gas here. It pushes the piston up, flows in here and cools down. And then this cool gas flows this way. Now we have one more problem. Over here, there's a high pressure. This gas is trying to expand. Over here, there's a low pressure because it's low temperature. So you need something over here at C to make the low temperature gas go this way. Otherwise, it won't. And so there's a pump at C that forces the cool gas back toward the boiler. And so what you get with this system is open this one, let the hot gas in there. This goes up, let it out to cool down, it goes down. Let in more of the hot stuff, it goes up, down, and this piston just goes up and down and, you know, performs work. This was the way steam, like train engines once worked. And this churning of this piston is what turned the wheels. And it's still the way that electricity is produced in power plants. It's just that instead of a coal fire and a engineer throwing coal into a fire, they have nuclear fission causing this high temperature, and so you can operate at a way higher temperature. Any questions about that basic idea? So next class, we'll be spending the whole time talking about calculations involving heat engines.